Hello everyone, my name is Jayanth.C and I am currently pursuing my BA in Sri Venkateshwar College of Engineering and I am from Basic Science Department. The subject which we are going to discuss today is Applied Mathematics for Svce stream and I am studying in first semester. These are the contents which we are going to discuss, that is Introduction to Conduction of Heat, Types of Conduction of Heat, Mathematical Formula, Differential Equations in Heat Conduction, Solution Methods, Engineering Applications and Conclusions. So let's begin the topic with introduction to heat conduction. What is heat conduction? Heat conduction is the fundamental process by which thermal energy travels through materials due to temperature differences. When two objects at different temperatures come into contact, heat spontaneously flows from the hotter object to the cooler one until thermal equilibrium is reached. This transfer occurs through direct contact between the object's particles, whether they are in solid, liquid or gas, and at its core, heat conduction is guided by the principle of energy transfer from regions of higher temperature to regions of lower temperature until thermal equilibrium is achieved. This phenomenon is essential understanding how materials respond to changes in the temperature and how heat moves within and between various substances. Let's know about types of conduction of heat. Heat conduction occurs in different mediums and under various conditions, leading to different types of conduction. The first is lattice conduction, which occurs in solids. In solids, this occurs primarily due to the vibration and the movement of atoms or molecules within the crystal lattice. The mechanism behind this is thermal energy is transferred through the lattice structure as particles oscillate, collide and transfer kinetic energy to the adjacent particles. Examples: metal conduct heat predominantly through lattice vibration. The next is free electron conduction, which occurs in metals. In metals, this is due to heat transfer happens through the movement of free electrons. The mechanism behind this is electrons being mobile transfer thermal energy by moving through the lattice and colliding with other particles, transferring energy in the process. The example for this is metals with high electron mobility like copper or silver conducts heat efficiently through this mechanism. Conduction in liquids. In liquids, heat transfer occurs through molecular collisions and diffusions. Unlike solids, liquids lack a fixed structure. Heat is transferred as molecules move and collide, disturbing thermal energy. Example: boiling water and other liquids conduct heat through this process. Conduction in gases. Similar to liquids, heat is transferred via molecular collisions mechanism. Gas molecules gain kinetic energy from a higher temperature region and collide with cooler molecules, transferring the thermal energy to them. Example: air and other gases transfer heat through this mechanism. So let's know mathematical formula or Fourier's law of conduction of heat. The Fourier's law of heat conduction is minus Qa dt by dx, where Q represents the heat transfer rate, K is material's thermal conductivity, A is the cross-section area, dt by dx denotes the temperature gradient along the direction of heat transfer. The next is heat conduction equation in one dimension, where del T by del small t is equals to alpha del square T by del x square, where T is temperature at specific point within the material, x represents the spatial coordinate, T represents time, and alpha is the thermal diffusibility involving thermal conductivity, density and specific heat capacity. The thermal diffusivity alpha is equals to K by rho C by P, where K is thermal conductivity of material, rho represents the material's density, C is the specific heat capacity. So let's discuss the differential equation of heat conduction. Differential equation governing heat conduction describes how temperature changes within a material over time and space. In its basic form, one-dimensional heat conduction without internal heat source is expressed as del T by del T is equals to alpha del square T by del x square. Here's the breakdown of the components, where T represents temperature at specific point within the material, X denotes the spatial position, T signifies time, and alpha stands for thermal diffusibility involving thermal conductivity K, density rho, and specific heat capacity C. This equation describes the relation between the spatial variation of temperature and its temporal variation within the material. It links now temperature changes over space with how it changes over time due to the material's ability to conduct heat. Let's know about solution methods. Several methods are employed to solve the differential equation governing heat conduction depending on the complexity of the problem and available resources. Here are some of common solution methods. They are analytical methods, separation of variables, assuming a solution in the form of product of functions of space and time. This technique simplifies the partial differential equation into ordinary differential equations that can be solved separately. The second one is similarity solution. Utilizes dimensionless variables to transfer the partial differential equation into an ordinary differential equation that can be solved using specific mathematical function. Second solution method is green functions. It utilizes known solution, that is green functions of simplified problems to derive solution for more complex boundary conditions. It involves convolving the green functions with the source term to obtain the solution. The next solution method is Laplace transform or Fourier transform. Transform the partial differential equation into an ordinary differential equation in a transformed domain, solves the transformed equation and then inversely transform the solution back into the original domain. The next solution method is perturbation methods, suitable for problems with small parameter variations. Solutions are obtained as series expansion where each term represents an increasing level of accuracy. These are some of the engineering applications of conduction of heat. In electronics and semiconductor devices, conduction of heat helps in the thermal management essential for cooling system in CPUs, GPUs and electronic devices to prevent overheating and maintain optimal performances. Whereas in automotive industry, it is used for engine cooling and braking system, whereas in engine cooling, it is vital for efficient engine operation, preventing overheating and optimizing performance. In braking system, it helps that managing heat dissipation in braking systems to prevent failure and maintain safety. The next application is building and construction. Insulation, critical for designing energy efficient buildings, reducing heat and cooling costs. HVAC systems, utilized in heating, ventilation and air conditioning to regulate indoor temperatures efficiently. Aerospace and aviation, aircraft engines, they are essential for thermal control systems, ensuring safety and performance in extreme conditions. Spacecraft design, managing heat dissipation and shielding from extreme temperature fluctuations. So this was the information about conduction of heat. Thank you for watching the video. Please like, share and subscribe.